Hi, this is Dr. Clark, and in this video we're going to learn how to study paired data. So two quantitative variables where the data is paired together. Let's get started. So the interesting thing about paired data is it's kind of like two means, but it becomes really one quantitative variable because of the pairing. And one common example is sort of before and after data. But if it's the same person before and after, then you've got two measurements, but we pair the data together in a certain way. So let's do a couple other examples that look similar to this. So let's say you wanted to compare grocery store prices between Fairway and Walmart. Are the prices different on average? Well, one thing you might think of is we'll just buy a bunch of groceries at Fairway, buy a bunch of groceries at Walmart, and see how much they cost here and how much they cost there. But the better way to do it would be to buy the exact same item at Fairway and Walmart and then look at the difference in prices. So you've got a particular brand, Cheerios, for example. It's the same size box, the same brand at both stores, and then you can see how the prices compare. Or you want to test the freshman 15. Do college students gain on average 15 pounds during their first year? Well, you could weigh all the freshmen and all the sophomores and see if there's a difference in average weight. But a better way to make it paired data would be to take the same students, weigh them freshman year and weigh them sophomore year, and then you've got paired data. So that's the idea. All right. And there's a lot of value in using paired data. So when you have one pair of quantitative response values for each observational unit, you've got this built-in comparison. The main thing is that it removes variability. So that's something to pay attention to. We're going to get stronger inference when we look at paired data than when we just have independent groups. Which means narrower confidence intervals and smaller p-values if we're trying to prove the null hypothesis to be false, which increases the power of our test. So this is a really good thing to do. So here's an example. We could look at exam data. So here's exam 1, maybe here's exam 1 and here's exam 2. And it looks like maybe on exam 2, the students kind of look like they did a little bit better than they did on exam 1. All these low scores kind of went up there. But you don't know necessarily which students did what. Maybe this student went down and this student went up. Who knows what happened, right? But did students do better on one exam versus the other exam? So you could do this like a two means test. You've got group 1, group 2, and that kind of thing. But with paired data, what you're going to do is you're going to pair each pair of these numbers and say, well, this student did 10 better, and this student did 20 better, and this student did 8 points worse, actually. And then you combine what looks like two groups of data by subtracting each pair into just a single group of data. And now you can see that almost all the data points are bigger than 0, which means that most students did better on the exam 2 versus the exam 1. And so now you can do a one mean test on the differences to see if the difference was 0 or if it was significantly different than 0. So that's the kind of thing we're thinking about with paired data. Hopefully that gives you kind of a nice introduction to the topic. And in the next video, we'll do some more examples.